Let us move to the next question, that is question number 13. An electron is accelerated through a potential difference of 10,000 volt. It is given in the question. Its de Broglie's wavelength is nearly how much? The mass of the electron is supplied to you. We already know that the mass of the electron is 9.1 into 10 to the power minus 31 kg. So, we need to calculate de Broglie's wavelength. It is from the chapter dual nature of radiation and matter, and the wavelength of electron has been calculated directly in your NCERT book, okay, which I have shown in the video. The explanation is there already. So, we know that the formula is lambda is equals to 12.27 angstrom divided by root over of voltage. Sometimes we write down as for stopping potential also. So, your voltage was supplied to you 12.27 divided by root over of, can you see the question, how much is the voltage? 10,000, right? That is how much? That only you have to do. Now, if you solve this one, your answer will come out to be 12.27 into 10 to the power minus 12 meter. As we know, Armstrong is nothing but 10 to the power minus 10 meter, right? So, check on the question which one is the correct answer. Your final answer will be option 2. Option 2 is the right answer. So, this is how you can solve question number 13. Let us move to question number 14 now. A copper rod of 88 centimeter and an aluminum rod of unknown length have their increase in length independent of increase in temperature. The length of aluminum rod is, you need to calculate the aluminum rod. Your temperature coefficient of aluminum as well as for copper is supplied to you. You just need to use a very simple formula and then your answer will come. Alpha Cu for copper and the length for copper will be equals to alpha, copper in which element is given to you, or which aluminum, okay, aluminum, and then length of the aluminum. So, alpha of copper and alpha of aluminum is supplied to you, and then the copper length is supplied to you. You need to calculate this length. I hope it will be easy for you. All the three quantities are known to you. Your final answer, if you solve this one, will come out to be 68 centimeter. 68 centimeter. You just have to apply simple mathematics on it. That's it. Your answer will be 68 centimeter. It's there? Yeah, it's there. So, this is the right answer. Fine. Question number 14 is done. Let us move to question number 15 now. Pick the wrong answer in the context with rainbow. What will be the wrong option we have to calculate, or you have to see from here? There are no solution. You just have to pick up the correct answer. Number 1. When the light rays undergo two internal reflection in a water drop, a secondary rainbow is formed. That is absolutely correct. It's a true answer. The order of color is reversed in the secondary rainbow. It is also true. Primary rainbow and secondary rainbow has got different order, right? An observer can see a rainbow when his front is towards the sun. That is the wrong option. It has to be back. So, number 3 is the correct answer. So, please click number 3. 3 is the right answer for the wrong option. This is the right answer, but it is a wrong option, right? So, let us move to the next question now. A body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down to the center of the earth? Now, this is a very good question from the chapter gravitation, and the solution I will show you here. This is my earth. My God, such a small earth. Yeah, this is just consideration. Fine. When it was on, the object was on the surface of the earth, how much was its mass or its weight? Weight was 200 Newton. Fine. Now, if you move halfway down the earth, this is the halfway, suppose at a depth d, since this is the center of the earth, let us consider of radius r. If it is going halfway, then it will be how much? R by 2. Now, which formula you need to use, my dear? You need to use this formula, g dash is equals to g 1 minus d by r. This formula we have already seen. Okay, acceleration due to gravity as we go below the earth's surface, right? So, what is your g dash? It can be written as mg dash, which is equals to mg 1 minus, in place of d I can write down as in place of d, that is r by 2, then r get cancel out. So finally what answer you will get? You will see that if you solve this one, your answer will come out to be 100 Newton. How much will be the answer? Just solve this one by yourself. mg dash can be written as mg divided by 2. So mg we already know how much, 200 divided by 2. Your answer will be 100 Newton. This is the final answer for question number 16. So check on the question. Number 4 is the correct answer. 100 Newton we got it, right? So you can click on it. I hope you have understood the procedure the way I have done. So let us see the next question now. If you look at the screen, you have a question number 17, which says 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and 0 internal resistance. The ratio of power consumed by the bulb when all are glowing. Okay. And number 2, in the situation where 2 from section A and 1 from section B are glowing. We need to calculate in the question that all the similar bulbs are connected. First of all, remember that similar bulb mean the bulb resistance will be same for each of them. We need to calculate first the power consumption by the bulbs when all of them are glowing, and second one we have to calculate when 2 from section A are glowing and 1 from section B are glowing, and then we can take the ratio of this one. So let us find it out and find the answer. When all the bulbs are glowing, I can make the diagram in that way. The resistance of the bulb will show me in that format, right? This is for section A, suppose, right? And then I have for section B separately. If I draw it, this is for section B. Okay, now they were connected to some EMF as shown in the screen. EMF E. Fine. This is section A and this is section B, each of resistance R, each of resistance R, right? Fine. Now, how much will be the combination of this one if I take the equivalent combination or equivalent resistance REQ when all of them were glowing? It will be R by 3 plus, again this one will be in parallel with this one should not be in connection, okay, please remember that. So plus R by 3. Now if they are in what? These two portion are in now series. So this is R equivalent. Your answer will come out to be, if I take 3 as LCM, R by twice R by 3. The power consumed will be written as E square by R. Now how much is E? Is it given in the question? It's not given in the question, so we'll keep it in that way only, and we'll write it down as E square by R will be how much? Twice R divided by 3. I can write it down 3 E square by twice R. So put it power 1 when all of them were glowing. Now I have a situation where only 2 from section A were glowing. So my diagram will look like this now. This is the combination of 2 resistance which will be in now parallel from the bulb side, and there will be 1 resistance connected here, and then EMF. If I have to keep this equation, that's why I am not drawing this one. This is R and this is R and this is also R. The combination of these two will be come out as R equivalent will be equals to 1 by R, 1 by, that is for parallel combination. So your answer will be R by 2 plus this combination will come as R by 2 and plus this R. So finally if I take LCM 2, you will get here R plus twice R, which will be 3 R by 2. This is your equivalent resistance. Fine. So what you will do? Again you will calculate the power. Power P2 will be equals to, you will write it down as E square by 3R and 2 will go up. 2 E square by 3R. Put it equation number 2. Now what you have to do? You have to just divide 2 by 1 or 1 by 2. Let me do 1 divided by 2. Now what is my 1? My 1 is, that is P1 by P2 I am doing. P1 is given to be 3e square divided by how much? Twice r, 2e square divided by 3r. Now you can calculate by cancelling them, and then your final answer will be, I think, e square get cancel, rr get cancel, and it will be 9:4. I think the answer will be 9:4. P1 by P2, 9:4. It's there in the solution and it is the correct answer. Number 2, 9:4. That is from question number 17. Now let us do question number 18. It says, for a p-type semiconductor, which of the following statements is true? You have to visualize p-type semiconductor at first. What do you have in p-type? Mostly are holes. Majority carriers are holes, minority carriers are electrons. Okay, let us see the options now. Electrons are the majority carriers. Cancel number 1, it is not true. Holes are the majority carriers and trivalent atom are the dopants. Yes, it is, because if you dope with pentavalent, there will be extra electrons, but if we dope with trivalent, there will be extra holes. So number 2 is correct. Now let us see other options can also be correct. Number 3, holes are the majority carriers, but pentavalent atoms are the dopants. False. Electrons are the majority carriers, again false. So number 2 is the correct answer. Now let us tick the correct answer. Number 2 is the correct answer. Let us move to the next question, that is question number 19. Question number 19 says, average velocity of a particle executing simple harmonic motion in one complete vibration is, if you can see the option, a omega by 2, number 2 is a omega, number 3 is a omega square by 2, and number 4 is 0. As we know that the velocity of the particle executing simple harmonic motion is plus minus a omega. Now if you start taking the average of this one, then it will come as 0, because plus minus a omega, what average it can give? It will be 0. So your correct answer is option number 4. So option 4 is the correct answer. So I will take this one. Now let us move to question number 20 and see what it has. Question number 20 says, the unit of thermal conductivity is joule meter per Kelvin, joule per meter per Kelvin, watt meter per Kelvin, or watt per meter per Kelvin. As we know, this is a direct question from the chapter, which one? Thermal properties of matter, that is thermal conductivity. That point you have to study. You will see that the unit is completely given there and the answer is number 4. So option 4 is the correct answer. So I can take on option 4. So now let us move to the next question, that is question number 21. Question number 21, it says, a solid cylinder of mass 2 kg and radius 4 centimeter rotating about its axis at the rate of 3 revolutions per minute. The torque required to stop after 2 pi revolutions is, you need to calculate the torque, and that is from the chapter system of rotational bodies or system of particles, which is in class 11. If you study this chapter, this question would be very easy for you. Which formula you need to use, I will tell you that. Now later you will have to apply that. So the formula which you will be using is work done is equals to half I omega f square minus, that is the final, and omega initial square. Yeah, that is somewhat similar to work energy theorem, right? Work done is equals to change in kinetic energy. So work done can be written as torque multiplied with theta, yes or no? Okay, half I omega f square minus omega I square. Now you have all the values supplied to you in the question. You need to calculate only which one? You need to calculate this torque. I hope this one will be easy for you, and let me tell you the answer. The answer will come out to be 2 into 10 to the power minus 6 Newton meter. Option number A will be your correct answer. Please put the values and see it. So number 1 is your correct answer. So let us move to the next question, that is question number 22. In question number 22, it says a force F is equals to 20 plus 10y acts on a particle in y direction, where F is in Newton and y in meter. Work done by this force to move the particle from y equals to 0 to y equals to 1 meter is, you need to calculate work done, right? So how do you calculate work done? That is from the chapter work, power and energy. Work done is nothing but your force multiplied with displacement. Okay, now from where to where limit is given? Y equals to 0 to y equals to 1 meter. So work done, or the small work done, can be written as dw is equals to f of dy. Now I need to calculate the total work done, right? So it will be integration of dw, which will come out to be w only, and integration from 0 to 1, f is given to you in the question itself, that is 20 plus 10y multiplied with dy. Now you need to differentiate with respect to y. So how do we do it? So integration of 0 to 1, 20 dy plus integration from 0 to 1, 10y dy. Now if I calculate it, 20 being constant will come out, integration of dy is y, so 20 y, and you will put lower limit and upper limit, plus here will be 10, integration of y dy is y square by 2, 2 will come out, let me keep inside y square, that is 0 to 1. Now if I put the upper limit and the lower limit, it will come out to be, upper limit is 1, so 1 multiplied with 20 will be 20, right? And again here it will be 5, and then if you put the upper limit, it will be how much? It will be again y square 1. So answer is coming out to be 25 joule if you put upper limit and lower limit. 20 plus 5, 25 joule. So your correct answer is option number 3, I guess, that is 25 joule. So it can be calculated easily. Let us move to the next question, that is question number 23. Question number 23 says, which of the following acts as a circuit protecting device? Number 1, conductor. Number 2, inductor. Number 3, switch. Number 4, fuse. It's a very easy question. You have done it in class 10 also, and then it is there in current electricity chapter also. What happens when there are too much load in your home, too much current flows in your home? The fuse wire breaks, right? That fuse actually help us to protect. Otherwise the current too much will flow and you might catch fire in your house. So fuse is a device which help us to protect the circuit. So the right answer will be option number 4, that is fuse. So option 4 is the correct answer. Now let us move to the next question, that is question number 24. Now we will be discussing question number 24, which says, in the circuit shown below, the readings of the voltmeter and the ammeter will be. If you can look at the diagram, you need to calculate its voltage and its current. Now please look at it very carefully. If you see, this 10 volt is connected to this resistance 10 ohm in this 2 point. The potential difference across this 10 ohm will be nothing but your 10 volt only. Now if I check the next one, that is the circuit 2, the 10 volt, again it is connected to the common potential difference of this 10 ohm. So the voltage which will appear on 10 ohm, this one will be same 10 volt, and this one will be also 10 volt. So your V1 and V2 will be 10 volt. Now the current passing through them will also be same 10 ohm, 10 volt. How much will be the current? V equals to IR, that means it will be 1 ohm. Similarly out here the current will be same 10 volt, 10 ohm. So current will be 1 ampere. Again 10 volt, 10 ohm, the current will be 1 ampere. Now if I need to choose the option, the correct option will be option number 3. So the right answer is V1 is equals to V2, right? And I1 is equals to I2. Both are getting same. So number 3 is the correct answer. Now let us move to the next question. Question number 25 says a hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere at a distance r from the center is. This is a direct question from the chapter Electric Charges and Field of class 12, that is chapter number 1. Increases as r increases for r less than capital R and for r greater than capital R. Capital R is the radius of the sphere, as we know. So this is not the correct answer. Number 2, 0 as r increases for r less than r, decreases as r increases for small r greater than capital R. So option 2 is correct. Now there can be two answers also in the same question. So let us see number 3. 0 as r increases for r less than r, increases as r increases for, no, this is not the correct answer. Option 4, decreases as r increases for small r less than capital R, that is also not the correct answer. So your final answer will be option number 2. So 2 is the correct answer. So I can write it down as, you can click on it, number 2. This is how you can solve.